Oh there, so let's find the greatest common factor, or GCF, between the numbers 84 and 154. The GCF, also known as the GCD, which also means greatest common divisor instead of factor, depending on your teacher, they both mean the same thing. In the case of just two numbers, so we have 84 and 154, they are just other numbers. Well, first, we have to know what a factor is. So what is a factor? Basically, a factor are just other numbers that multiply together to get the original numbers. So let's just say we have 12 as our original number. Well, we can have 4 and 3 and 2. So the factors can be either can be 4, 3, and there's also some 2's. So these are all factors of 12, the original number. So they're just two numbers that multiply together to get the original number, 12. Specifically for integers like these, the factors are just integers. Usually they're smaller, that multiply together to get the original numbers. And common factors, so let's just say we have 12, 24, it says in 4 and 6, and then 3 and 4. Common factors are just numbers that are the same between these two original numbers. So a common factor for 12 and 24 is 4. Okay? So the GCF is the greatest common factor. It's exactly what it says. And it's only one number. Instead of two common numbers, there's only one. We're only looking for the greatest one between the two numbers. It can also be more than two. We can have three. We look for GCF of 3 numbers or 4. And for now, instead of integers, we're only looking at positive integers. So the GCF should just be a positive integer, or just a positive number. So let's just go ahead and find the GCF. To do this, we first need to know that every number has a prime factorization. Remember how I factored 12 into 3 and 4 and 2 and 2? Prime numbers, you can always prime factorize, also known as break them up, factor them up by dividing them into prime numbers. So 3 is already a prime number, and then 2 and 2 are prime numbers, and every number has a prime factorization when you divide all of them up. Again, you should only get one number for the GCF, so let's just prime factorize. So first step is to prime factorize 84 and 154. There's many ways to do it. They're both even numbers, so you can both divide them into 2. But you can also divide 84 by 4 and 21. 2 and 2, we can stop here because these are both prime numbers already. We can break 21 up by 7 and 3, and they're both prime numbers, so we can stop there. 154 is a bit bigger, but I know that it's divisible by 2 because it's an even number. So that's 77 and 2, and that's 7 and 11. Okay, and those are both prime already. So what we see now is we look at the common factors between them. So there's a 2 here, and there's a 2 here. So we can already have our GCF 2, and then we also see that there's a 7 here, and there's a 7 here. So we have to multiply by 7. And those are the only 2 common factors. To get the GCF, we just multiply the common factors all up that are between them, and the GCF is between 84 and 154, also known as the GCD, is 14. We have another example, but now GCF does not always have to mean numbers in general. We can talk about variables. Now, it's a little bit different how you would calculate or define them with variables instead, but here's how you would do it. So we have x squared. Just write them all in a line. And remember how you can factorize just like how with normal numbers by breaking them up into numbers, in this case now variables that multiply together to get the original number. This time it's just a variable. Well, we can break them up in the same way. X squared is just x times x, and x cubed, or x to the power 3, is just x times x, and then times x, and then x4 is just x times x 4 times. And then we can find our GCF by just looking at the common factors again. So that's the x in common here, x common here, x common here. That's one x in common between all of them. X, and x. And that's another x that's common between all of them. But now there's no more x here. And there is an x here, but there is an x here, so there's common between these two, but not all three. We're looking for the greatest common factor of all three. So we only have x times x. The GCF is x squared. Let's go look at the more complicated example of variables. So now there's two variables. There's x and y. So again, I would just rewrite it. Common habit to rewrite it. And we look at what's common between them. X, and then a y, and then multiplied by another y, and then another y. This is y cubed, and then this is a single x there. And then here it's x, and then x. We do it 4 times, y, and y, all being multiplied. This is x to the power 4 and y squared. And then we just do the same method that we did to find the GCF between these two variables, these two expressions. We have an x in common, so I'm just going to circle to the x, and an x in common here. That's one x. There's a y that's common between them. There's a y. And there's another y here. Another y here. It's common between them. Now, is there anything else that's common between them? There's a y, but there's no more y's here. There's an x, but there's no more x's here. So this is the greatest common factor between them. X, y squared. Now, you might be thinking, is there a better way to do this? Well, after doing imagine if you had a y to the power 6, you have to write y 6 times, which will be very tedious. Well, there is a strategy to do this, but it only works for variables. So if you just look at xy squared, y cubed, you can just say the smallest variable power between them. Now, I'll show you what that means. So the smallest variable exponent, I guess for this example, is x squared. It's smaller than, it's least out of all of the exponents, 3 and 4. Okay? So the GCF is x squared. Very easy shortcut. Well, for two variables, well, you might have to look at x and y individually. The smallest power for the variable, for the x, is just x. See right there. And the smallest variable for the y's is squared, 2. Right there. That's the GCF. Very easy shortcut. When you do a bunch of these, feel free to do that instead. But doing it this way shows you how we got the GCF in the first place. But how about we take the greatest common factor, GCF, of both, a combination of both numbers, here coefficients, and variables. So again, Let's write it down in a line. And then 15. Well, you can do, after doing a bunch of these examples, you can already know what the GCF is. I know I do. Well, let's just do our method from before. 10 can be divided, 10, 5, and 15. Notice how it's also three numbers. You can find the GCF of three numbers instead of two numbers, or even four numbers, five numbers. But it's always going to be one answer for the greatest common factor. So first, look at the numbers or coefficients. You need to focus on them individually because the GCF and finding the GCF of numbers and variables are different ways to do it. So focus on numbers first. 10 can be divided up into 5, 2. They're both prime, so we're good there. 5 is just already a prime number, so it's 5. And then 15 can be divided into 3 and 5. Those are the factors. And find the GCF of the numbers. I'm just going to write it in lowercase. And there's a 5, there's a 5, there's a 5. Right here. And is there any other numbers that are common between them? Nope, there's no 2 here, no 2 here. There's no 3 in any of these. So the GCF of the numbers is just 5. Now for the variables. Well, we have x squared, x to the power 4, x to the power 6. You can do it traditionally, the longer way, by breaking them up all the x's, and then here's the 6's. It's a lot. Yes, and then the GCF of the variables, there's 1x here, 1x here, 1x here, so that there's 1x, 1x here, 1x here, 1x here, so there's another x, and there's no more x on this side, so you know the GCF is just x squared. Shorthandedly, you can use a shortcut. The smallest variable exponent is 2 out of these three numbers, so the GCF is just going to be x squared anyways. And you just put them together since we're looking at this set of numbers. So the GCF of these set of numbers from the start is 5x squared. Okay? Make sense? Oh, x cubed. It meant to be x cubed. So there is going to be another x here. 1, and then there's x common in all of them. So it's x cubed, not x squared. Apologies. But it's still the same method. It's still the smallest exponent, so it is x cubed. So 5x cubed is your greatest common factor between these. And then we'll get into LCM, but we won't get into LCM with variables because there's not really any practical applications for it, at least not that I know of. To save time for this video, GCF most of the time will be more important, at least for this context. So what is a least common multiple? Well, first off, it's exactly what it is. First, a number or a multiple. So what is a multiple first? A multiple of a number is the product when you multiply that number by any other number. So let's just say 4. A multiple of 4 is 8 because you can multiply 4 times 2 to get 8. So 8 is a multiple of 4. It's not the only multiple though, there's many multiples. So the multiples of 4 are 8, 12, 24, you get it, 64. There's a lot of multiples and keep going. And those are all multiples of 4. Even 4 is a multiple of 4. You just multiply it by 1, you get 4. Okay, so now we know what a multiple is. To get the least common multiple, that's one number. So again, like how GCF is one number, we're only looking for the least common multiple, which is one number between a set of numbers. Here, let's find the least common multiple, or LCM, of 8, 35, and 40. Again, every number can be reduced to prime factors, so you just divide them. It's 4 and 2, and then 2. Now they're all prime, so we can stop. 5 and 7, they're all prime, so we can stop. And then we have 10, 4, 5, 2, all prime, we can stop. 2 and 2, all prime, we can stop. Now the LCM, there's many different ways to do it, or many ways to show how you find it. This is how my teacher taught us how to do it. It's very organized. We write the numbers all in this column here. And let's look. And you put columns for each number, but you line them up so they're all lined up in the column like this. So let's just say find all the ones that are common, or not even common, just list them all out. So there's a 2, and there's a 2 here, and there's a 2 here. So you have to include all of them. Next, a 35 has 5. There's already spaces for the 2, so we put them on the next line. So you see the space for the 2 here, or for the 2 here. And 5 is there. 7, you can put it right there, this column. And for 40, there's a 5. We already have a column for the 5, so we put a 5 there. And 3 2s. 1, 2, 3. Now, conveniently, to find the LCM, you just bring them all down. So a 2 and a 2 is 1, 2 there. 2 and a 2, 1, 2 there. 2 and a 2, another 2. 5 and 5, it's another 5. And then the 7 at the end, it's just a 7. Now you just multiply them out. So LCM, or least common multiple, is just, you can write it in the notation of exponents. So 2 to the power 3, 2 cubed, times 5 times 7. That should get you 280. That is your LCM, the least common multiple of these 3 numbers. And hopefully this helps, and wish you a great day.